and
we're recording now.
Okay, we want it to be we want it to promote return on investment, and we want it to be viewed by appropriators in the sense of being credible, and that they can see what they would be getting for their money, and work both sort of up and down the accountability scale from the national level down to the landscape. So the next thing we're going to do is provide a little background on STARfire. So we're going to kind of build this national appropriation from the landscape level, and we're going to go up from there. So first, what is STARfire? So we're going to work with this process using the STARfire system. And STARfire, if you haven't heard of it before, is a national spatial budgeting and planning system that integrates fuels analysis, preparedness analysis, and it does risk assessment, all guided by return on investment. It works at different scales. It could be scaled from the planning unit to the regional and national levels. And that's kind of what the focus of what we're going to do today is. We're going to work from the unit level and then just go right into the national level. It also works at a variety of application sizes. We can apply this system at the planning unit level, which would be like a national park or a refuge or a national forest. We could also apply it at the state size, at the state level. And currently, we're working with the entire state of Idaho with the BLM in terms of producing the materials and background and analysis to do an entire state plan for all of their districts. And it will integrate their different districts as well. We are also able to apply it at a large scale. A year or two ago, we applied it across 17 million acres of the Great Basin to do field treatments for the great sage grouse. So that was another large-scale application. So we work at various sizes, and we also have the ability to scale. Why do we have a system like this, and why are we building out a system like this? Because agencies are really pressured to provide defensible analysis that's backed by data and in a spatial context. And these systems now need to be able to help guide decisions, and they also need to be able to help defense decisions that are made. We're in an age of the development of analytical systems, and we also want to be able to demonstrate a common metric of performance that's very well accepted, return on investment, and in fact required by the DOI Department of Policy Analysis at the national level. STARfire provides decision support for planners and agencies. It works with budget and cost accountability across the fire program, and accountability hasn't been as strong as it has been in previous years, but with a $2 billion suppression expenditure this year, and that's just the Forest Service up to this point, plus other agencies, plus state and private, there's a pretty good signal that the age of accountability hasn't really left us, and we're going to have some questions to be answering in a short period of time. And down in the lower right is our little bean counter guy. So we like him. He's kind of a pain in the neck, but he's always there. So what does STARfire do for us? And we're going to take a look now. We're going to work through 3 different levels: the landscape analysis. Then we're going to build out programs at the landscape level, and then we're going to use those in order to reach a national level analysis. For this study, we used 4 study sites. We used Glacier National Park, Sequoia and Kings Canyon National Parks, Shenandoah, and Big Cypress. This range of parks gave us a chance to work with very disparate ecosystems, very different geographic locations, and then so that what we wanted to do was be able to demonstrate the ability to look across an entire nation. So we're going to use a 4-park kind of build out here, And at the same time, we're going to imagine if in the future we did a build out like this, it would include the entire United States. So it would include all of the park systems in the United States, or it could include, it could be all BLM or all forest or whatever agency was involved here. At this point, we've worked with over 20 national parks with our analysis, but for this particular build out, we're going to just work with these 4 since they provide us a really good range of different kinds of ecosystems and problems and so on. So here we're going to start at the landscape analysis. We're going to generate the core data sets to do the analysis. We're going to assess the landscape return on investment by program, and we're going to locate and prioritize fuel treatments. And we're going to modify core data sets to reflect the fuel treatment. So we'll look at the landscape before the fuel treatment. We'll look at it after the fuel treatment, and that difference will tell us how much improvement we were able to make to the landscape. We'll evaluate the value added from doing these fuel treatments, and then we're going to put that in the context of value added from preparedness modeling. In the next section, we'll take a look at how to put this into a programmatic context, and then finally the national context. So a little background on STARfire. STARfire is a spatial planning and budgeting system. It works with 3 core sets of inputs. The first set of inputs it works with are fire affected values. And it works with the entire range of values, whether they're ecosystem values, life and property. As long as we can represent them spatially on the landscape, we'll use those values, and we'll use a wide range of values. The next set has to do with burn potential, and that includes fire history, burning probabilities, ignition probabilities, and so on. All of those are combined in there. And then finally, the management costs, the cost of doing fuel treatments, the cost of doing preparedness is included. And by combining the management costs with the values, that'll get us our return on investment that comes out the other end. By looking at all of those, we then assess how much value added can we produce on the landscape from various fire management activities, primarily preparedness and fuels treatment. This will produce outputs for us in terms of a basic risk assessment, fuel treatment optimization, and then preparedness, all driven by return on investment. And then we're going to bring those into budget formation and allocation at the national level. The first output at the landscape level is really a risk assessment. And what this risk assessment output shows us is where wildfires are most likely to generate benefits on the landscape, shown in green, and where wildfires on the landscape are most likely to produce detrimental outcomes, and those are shown on red. This risk assessment includes almost all of the parts of STARfire, and it gives us a first check on the system. It allows us to check for the values, the fuel treatments, the fuel models, and so on. So we usually take a look at this and engage the fire planners at the site to make sure that this is sort of passes the truth test. It also includes spread. So spread's included in here. A lot of the really dark areas include life and property, and at this particular site, they also include some of the trees and groves that are considered to be national treasures. It also shows some areas in green where introducing fire in the landscape really could help keep, encroachment from species like fir and other undergrowth, and help clean out some of the ecosystems to improve the quality. So anyway, that's the first. The risk assessment is the first. It's has a number of uses. So it's been found useful for taking a look at large fires and large fire spread, because the entire landscape has been pre-processed. Next thing that we produce at at the landscape scale are fuel treatment locations. These are fuel treatments that are located by the computer or by the computer system on the landscape. They reflect hazard fuel reduction and the value of hazard fuel reduction, as well as the ability to use fuel treatments to improve the value of the ecosystem or ecosystem improvement. Those two are combined together. And what we're showing on the left-hand side with the bars are the number of fuel treatment acres that are driven by increasing budgets. And then we show how much value added we can get on the landscape by increasing the amount of fuel treatment. Also in the map on the right, the fuel treatment is shown from small, the higher the acreage that's shown, the lower the priority. So at lower treatment acreage, we get higher priority. And then as the budget is expanded out, lower priority acres come into play. So we optimize and then we prioritize the fuel treatments on each landscape. For this demonstration and for the Joint Fire Science Project, we used 4 different landscapes, and we did the fuel treatments across a wide range of budget levels for each of the landscapes. That includes Shenandoah, the Big Cypress Glacier, and Sequoia landscape that we just showed in more detail. So now all of these are going to be done independently. And then what we're going to do is put this together to get the budget formation for, assuming that we're going to work with this as if it was a national allocation, but just with an example of 4. So, and in each one, we're going to demonstrate fuel treatment locations from high priority to low priority, depending on how much budget would be allocated to the individual park. We also have, you may have noticed, we also have areas that are excluded from treatment, and these are areas that either wouldn't burn or that fuel managers have identified as areas that they just wouldn't treat because to them it doesn't make sense, so we take those off the table right away. The other thing that's included in here is a preparedness module. And that's not really the focus of what we're doing today, but we're doing our fuel treatments in a context of preparedness. When we work with preparedness, we work with both loss mitigation, which is really initial attack, plus the ability to work with beneficial wildfire across the landscape, lightning-started fires primarily, that we want to promote through the preparedness activities. And we're going to put those two together without going into detail about how preparedness is programmed and worked, with the kinds of inputs to also tell a lot about the preparedness program. The first one is how close is a cell to the nearest dispatch location. That affects how can we get there and can we affect the probability of fire escaping. And that's all. That distance is then measured in time. We also work with spread rates on a landscape that come from the fuel models and the weather. And if we do, for example, a fuel treatment, we affect the spread rate, that in turn affects the preparedness module. So that these two programs are kind of tied together. And that's why we're doing fuels in the context of preparedness. We also include ignition probabilities, and we're going to manage those through the preparedness. We have ignition probability that's measured from historical data. And then as we apply more and more preparedness resources to a site, we're going to really model that as if we were able to manage those ignition probabilities by keeping fire from spreading outside of a containment site area. And for loss mitigation part of this, we're going to identify the loss producing cells, and we're going to manage the probability that they're going to burn by increasing the preparedness budget. And also for the beneficial wildfire cells, we're going to manage the ability to introduce and the probability of introducing fire on those sites to get a beneficial effect from the preparedness module. That's all for this. That's all context. And we're going to show Ultimately, for preparedness on the landscape, we're going to show the amount of value added that we can get from loss mitigation, that is protecting life, property, critical habitat, and other resources, and also the amount of value added that we can get from introducing the beneficial wildfire. These two examples, one from Sequoia and one from Glacier, show that the amount of value added from beneficial wildfire relative to loss mitigation can greatly differ by site. And on the wetter sites like Glacier, where the fire return interval is much longer, the preparedness is not, the probability of ignitions are not as high, that the beneficial the beneficial wildfire component of this produces at Glacier a bigger proportion of the landscape benefit. And this will vary from site to site. So to do the program analysis, and what is STARfire going to do for us at the program analysis? We're going to be able to take a look at fuels and preparedness programs, and the two programs require a similar set of resource input, similar crews, similar planning, and similar kinds of equipment. And the interaction between these two is important. It's important in the sense that field treatments affect spread rates, which affect the amount of the probability that fires are going to escape initial attack. And then when we budget nationally across programs, the amount of budget that goes to one program affects the amount of budget that goes to the other. So this context of having the two together is really crucially important for getting a good picture of the national budget allocation. STARfire can quantify these relationships, and it does it using the value added and return on investment as a context. The next thing we're going to do is take a look at these in terms of a programmatic context. So we finished looking at the landscape and kind of at how we would work with this individually. And we're going to move now into programmatic analysis, which is programmatic analysis is a crucial stepping stone to be able to get us to the national analysis. So this is a key step. We're going to stay at the landscape level, but now we're going to take a look at sort of how to build out and view these as programs. And Brianna did a lot of work. Brianna's I should introduce her a little bit better. She's a graduate student here at Colorado State, working with the STARfire system and building out some of the mathematics for us in this and some of the programmatic programming concepts that we're using. She did some of the econometrics that are behind the scenes here in terms of building out these programs. And so I'm going to turn it over to Brianna here for just a little bit, and then we'll come back.
Hi. So first, the first portion of this, program analysis required us to create a production function for each of the parks. And this was actually a translog production function, and it estimates the value added given various preparedness and fuels treatment budgets. So as you can see, the pictures depict us plotting the observed values that we have against the estimated production function values for each of the parks. And that helps to validate our production functions in order to go on to the next step. This is when we create the surface. So in order to create the surface, we took all of our production function, estimated production function, value added estimates, and we're able to create our surface. And then we took the first derivative of each of the production functions, and from there we were able to create the path of steepest ascent on the surface. And this path of steepest ascent is basically the combination, various combinations of preparedness and fuels treatment budgets that get us the greatest value added. So as you can see, they differ based on different planning units. And then that brings us to the national level analysis that we conducted. And so, basically we did the same process. We created these gradients of different budgets, which helped us to create the path of steepest ascent for each of the parks. And we combined all of these in order to create the national budget. And so as you can see in blue, those are all the preparedness budgets for each of the parks. And in orange are all of the fuels budget for each of the parks. And it's separated out by each park. And then on the bottom, that is the total national budget and how each of these park programs would be allocated from there. So that's pretty much the gist of it.
Okay. So going back a little bit to sort of the final slide, by building out the programs, and then also building out a budget path across the surface of those programs, we then really perform the same analysis to get from the landscape to the national level, so that we can then identify across a full budget range. And we are able to do that by when Brianna made those production function surfaces, we get a smooth surface so that we can work across a full range of budgets, and then we can work across the different parks and the different programs in the parks, so that we can fully take a national budget, allocate it across the different parks and the different programs within the parks, all guided by keeping our return on investment healthy and headed in the right direction. And she talked about path, the steepest ascent. We're going to try to get the highest value added we can out of these budgets. And at the same time, we're going to do it in a way by using those gradients that keeps a stable program, a stable workforce, and so that we don't have swings in how the programs are managed that would be disruptive. And this turned out to be a fairly important part of really the overall economic approach. So for summary and conclusions, we start at the landscape level. We then turned that into a programmatic analysis, and then we took that program analysis and built out a national allocation, both by program and by location. This is really the first science-based budgeting formation and allocation approach that we have in fire and fuels management. It's kind of exciting to see that we can develop a system that is based on productivity, based on cost, based on return on investment, provides stable allocations in a consistent direction. It also embraces the principles of return on investment. It keeps the programs from swinging wildly from one direction to another. It also promotes the defensibility of the programs and the productivity of the programs, because we can take an allocation to any one of the parts on this national, any one of the bar segments, and we can take it and go back to those surfaces. For example, the surface at Big Cypress, we can go take the fuels program back to that surface, and then we can go back into the park and find out exactly where those allocations were made, what they did, what values were involved, and so on. So we can drill up and we can drill down to all of this. And again, many thanks to the team that worked on this, including Nikki Kernahan, who isn't able to be here today, to Andy Kirsch. Many of the ideas in this were hatched by Andy and worked through collaboratively with us here at Colorado State University to get this sort of pulled off. And many thanks, and thank you for joining us today. And I'm going to go see if Gloria if there's questions that we can address. Be glad to do that.
I was curious about your land type are earlier on when you were showing land type. You take small units, and how small are those? Are those acres? You might have addressed it, and I didn't really get that because I was messing around with it.
So the planning unit size that we use is roughly, the smallest scale that we tend to work at is like a planning unit, which would be the equivalent of a national park, and those come in various sizes too. A national park, or we could work at a state park or a national forest. And then the smallest we actually get is at the cellular level. So each one of those would be comprised of, say, thousands or millions of cells, and each one of the cells inside of that park is analyzed.
Then the cells are generated by a GIS unit?
Yeah, the cell. So when we start, the system is geospatial. And so when we start the analytical process, we really work with a cell size, and we work with various cell sizes depending on how big of a problem we have. If it's a small scale problem, we might work with a 30 meter or 120 meter cell size. And as we work on bigger, larger systems, just for computational efficiency, we might have to move up to 220 or 480 cell size, just depending on what the problem is and what the questions are that are being asked. So cell size is really defined at the beginning of the analysis to fit the problem. And at the cell level, all the values work at the cell level. The fuel models work at the fuel level. All the burn probabilities, ignition probabilities are calculated at the cellular level. So everything really starts at the cellular level in the context of the planning unit. And then we kind of work, it's like an onion, I guess, is a way to look at it. We have this sort of the cell size that's defined at the beginning. That collection of cells gives us a landscape to work with. And then once we understand a landscape, we can start working with a programmatic analysis, and then we can build that out to a national picture, a national allocation.
We do have a question. Can you show the bar graph again showing return on investment from increased or decreased funding on preparedness versus beneficial fire? The return on investment, if I recall, didn't seem that drastically different. What am I missing?
Sometimes it's not drastically different. I'm not quite sure which illustration that is.
You just passed it.
This one?
Wait, hold on. No.
Next one.
No.
Next.
That one.
This one.
Yes.
Yeah, sometimes they don't seem to be. Sometimes they aren't. Sometimes the surface, and I can explain why. It kind of depends on where we are in the budget, and as you increase the budget, how much value added do you get? So the first thing is as you start out, I'm going to go back to the skirts that we have in the programmatic analysis. So each one of these 3D illustrations shows the amount spent on preparedness on the x-axis, the amount spent on fuels on the y, and then the surface shows the amount of value added that's produced out of those two programs. To answer your question, which is a really good one, you notice as you get up over kind of the initial rise, it's relatively flat. And the reason for that is that the value of protecting life and property is really quite high relative to the other values. And it is our highest priority in fire management. And so usually what's happening is you get this really rapid rise as you're using fuel dollars in protecting the wildland-urban interface and preparedness funds in also protecting life and property. You get sort of a rapid rise in value added, and then it's going to usually level off a little bit, and in most of these cases maybe level off quite a lot as we work into other values that aren't as high and the surface isn't as steep. And that's why across those bars you're not seeing a very large change, because we're operating primarily across the flatter part of the surface there.
Okay.
A good question.
Next question is, Janie says, thank you. Corey Blankenship asks, where do the fuels data come from that are used in the model?
Oh, that's a good question. So in fuels, there's a lot of, I'm not sure exactly which part of the data you're asking about. So we use a full set of fuel models. Fuel models are mapped across the entire landscape. The values that are affected by fuels are also included, and they're mapped across the landscape, and they're managed by sort of ecosystem condition and fire behavior, which would be whether we have high intensity fires or low intensity fires, and that's all calculated by Flam Map. So there's a whole lot of data that goes in here. I'm not exactly sure what part that all of it works with fuels.
She asked, sounded like you used a spatial fuels layer.
Yes, we did. So we do use the spatial fuels layer.
From national parks or land fire?
That's a good, okay, so whether it's from national parks or land fire, so we use the best data that we can get. And sometimes we have to start with land fire, and we're well aware that everybody has an issue with land fire data. And so what we often do is take the land fire data, and then we'll work with the national park. If there's better layers or better knowledge, we'll then adjust that appropriately with the planning unit to get the best spatial representation of the fuel models that we can. So it kind of depends. So
you're saying that this software is adaptable to different types of resources for spatial layers and data?
Yeah, so we just take we just map out spatially the fuel models as they would occur on the landscape, and where that comes from, STARfire doesn't really care. Okay. And so we just use whatever the best available is. Sometimes the best available is land fire, and many times the planning units have ways of improving that, either through their own analysis or by adapting the land fire data.
Okay.
Mm-hmm.
We still have time for other questions. Oops. Yeah. Brianna, is there anything else you wanted to discuss? No?
I might, so we have just a little bit of time here. I might mention these surfaces. So what happens is STARfire produces like a grid of results across preparedness and fuels. And you can kind of see that on the skirts here that are shown. See the little dots? Those dots are produced as discrete points, and they're first produced by STARfire, and then what happens is we use an econometric method those are input into the econometrics, and then we reproduce a set of dots, and that's what Brianna is showing here, the two sets of dots. One was produced by STARfire, and then one was estimated by the econometric function. Then the function is put together it's represented by really an equation so that we get the smooth surface that you're seeing here. So we go from the dots to the surface. Then once we have the surface, we build the path, the dark line that you see, which is the path of steepest descent, which at every budget level shows us how much more return on investment we can get without being disruptive to the program. This is a what's called the gradient method. It comes from engineering systems, but it also has an important economic application because it combines the value of producing value added, but it also includes implicitly the cost of being disruptive to the workforce. So you'll notice that as we move along that gradient, you'll see gentle changes as we work our way across the surface to get higher and higher levels of value added. That's what happens at each park or each planning unit. And then we do the same thing in effect to get the national allocation, which would be like a gradient across the think of it as a gradient across the national system. So this is a new approach to budgeting. It conforms with the basic principles that people seem to want in terms of policy, and we try to get it to conform with being practical in the sense that we don't have a whole big allocation to one side or the other that would be disruptive, but still try to be defensible in terms of both the appropriators and then being able to defend our programs in terms of telling people what they got for the expenditure. And it's repeatable.
We have one more question. Do you see this, or how could this be applied to suppression approaches versus the mitigation discussion?
Well, that's
suppression versus mitigation approaches. Are those two separate budgets on the same land in different parts of a landscape? Would this encompass both suppression and mitigation?
So it depends. Suppression, we work with the sort of the initial attack side of suppression. We don't really work with the large fire side of it. And the reason that we don't work with large fires is that their probability of occurrence is kind of pretty low for this kind of a probabilistic model. And the other reason is that they're too hard to predict. They're too hard to model in terms of fire behavior. So we work with the initial attack side. And then the other part of that was it prevention?
Suppression versus mitigation.
Mitigation. So I guess it depends on what you would mean by mitigation. Fuel treatments can be viewed as a mitigation effort. They mitigate the occurrence of large fire. They mitigate damages that might occur by fire and so on. So mitigation in a fuel treatment context is included in here. Mitigation in terms of prevention, we don't have that piece, and there's probably reasons for that, but some of them have to do with representing it spatially. There are other modules that can be built out in STARfire, and I think there's some interest in building out a restoration module that we've talked with a number of folks about doing, but haven't really started that. We kind of have our hands full with this part.
Okay.
So.
I don't see any other. Oh wait, a restoration module will be great. Jeannie Montblanc suggested a restoration module would be great, and Erin says thank you for the clarification. Any other thoughts? I'm not seeing any responses. Okay.
Great. Well, thank you all for attending today. It's a pleasure being able to connect with all of you, and it's a pleasure really to be able to be involved with this kind of work. with the federal agencies, and it's really exciting to be able to move these systems forward in ways that hopefully are meaningful to at both the national scale and also in terms of just even planning fuel treatments. So it's pretty exciting. And you're seeing a rising star here in Brianna, so you might keep that in mind. Some of her talent and expertise has really shown up in some of the econometrics that are behind this. So if you are interested in additional information, we have a lot of publications. They're available. I think there's a reference down at the bottom to my ResearchGate site. I put everything on there. We could get it more focused, but I just didn't have time to put together a list. But we do have publications on preparedness and some of this national budgeting material. We have got some of it out, and we'll probably have more publications on it soon.
Okay. And what's the main website they should go to? It looks like it's cut off down there.
Yeah, on my screen it's cut off. I don't know if it is on yours. I will assume that there's...
No, it's cut off on mine too.
It's cut off? Okay. Well, let's see. Does
there
that?
You go. Yep.
There we go.
ResearchGate net profile doubles Rideout to contributors. Okay.
Or just Google me on ResearchGate. Either way, that's the easiest way. And then if you want a specific list or some help or pointers, we're happy to do that too. Happy to share whatever we can. So again, many thanks to you all for attending today. And it's pretty exciting being able to be involved with these sorts of things. So.
Okay, thank you all for attending. This is the end of the webinar, and be sure to check out the Southern Rockies Fire Science YouTube channel. We'll be posting the webinar then. Now going to turn off recording, and we'll close the webinar. Thank you. Have a great weekend, everybody.